now that we've gone through this activity and we see which outcomes are going to come up more often, so we know what their probabilities or chances of them occurring are. We know that these middle ones are going to come up more often. We can link that to what's going to come up in algebra and write down an algebraic expression for it. Well, let's think about this. If we're going to flip the coin one time, we could end up with a red, and I'm just going to call that R, or a yellow. And we're flipping it once, so the 1 is up there. Red or yellow. Okay, so what happens when we flip it 2 times? Well, we can end up with a red or a yellow on 2 different flips. So we can expand this out, and there's one way that we can get 2 reds. So I'll stick a 1 there. And there are 2 ways that we can end up with a red and a yellow. And there's one way that we can end up with 2. When we look at these numbers, the 1, the 2, and the 1, those are called coefficients. If we come over to our triangle here, look at that. 1, 2, 1. So the numbers in our triangles match what we see in the algebraic expression. Let's try one more. What happens if we flip a coin 3 times? We can end up with a red or a yellow for each of 3 flips. Okay, so let's think about what kind of outcomes that we could end up with. Well, we do it 3 times, so we could end up with a R, 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 so 3 reds. And we'll save this number. We'll talk about that soon. Or we could end up with 2 reds and yellow. Or we could end up with 1 red and 2 yellows. Or we could end up with all yellow. So there are numbers or coefficients in front of these things. I wonder if we can use what we discovered with this one to help us out with those numbers. Let's go over here. So 3 flips, we're looking at this line, 1, 3, 3, 1. That 1, this one here means 3 reds. This one means 3 yellows. And these 3s relate to these other outcomes that we mentioned. So 2 reds and 1 yellow, or 1 red and 2 yellows. So now we can come over here. We know that these 2, all reds, all yellows, have 1 in front of them, and the other 2 possibilities have 3s. And we can simplify things here a little bit, just like we did when we were counting up the number of paths to get to the paths across each outcome, or each number of flips. Remember, we were saying 2 squared, 2 to the power of 3. Here we have R times R, or 2 R's, so we can just say R to the power of 2. This one we need to leave the same. We can't simplify that. Over here we can do Y to the power of 2 though. And down here we have 3 R's. So R to the power of 3. Here we can stick these 2 R's together. So R to the power of 2 times Y. And then over here we have R, and then we have Y to the power of 2. And finally, Y to the power of 3. So in high school then, a problem that you might see is you don't see things in terms of R's and Y's necessarily. You might see a problem that's X plus Y to the power of 4, say. How do you think you might tackle that one? It looks sort of like this one. You could multiply it all out through the steps, but you'll see that's kind of tedious. Maybe we can use what we know about Pascal's triangle and our 4 flips and the idea of the number of paths that we can follow through to get to those, to come up with the numbers that would go in front of each of the possibilities or each of these combinations of X and Y's. it turns out that does work. And that's going to work for you regardless of how big this number is here. You just have to know that you have to go down that many steps of the triangle. Okay, so in this activity, we started with the idea of randomness and probability, flipping these little coins. And in doing that, going through this activity, we discovered the Pascal's triangle. And now we're seeing that it's connected to algebra. So there's all these different ways of looking at the same situations and getting to the same answer. That's the beauty of mathematics.